So write down the problem here. A is equal to the age frequency is equal to 0.08. B is equal to 0.10. Okay, so B is equal to 0.1. C is equal to 0.12. D is equal to 0.15. E is equal to 0.2 and F equal to 0.35. To verify, you can just do the addition, that this addition comes out to be, sum comes out to be 1. So that's the first thing. So this is the frequencies given to us. Now we'll try to find prefix codes using the Huffman algorithm. So to find the prefix codes, write all the known characters with ascending order of frequencies. So A, B, C, D, E. Write down the frequencies. So frequency is not 8, not 8, 0.1, 1, 2, 1, 5, 0.2. Now select the two smallest frequencies, so 0.08 and 0.1, and combine them and sort it. After sorting, the first frequency that will come up is C, 0.12. The second one that will come up is D, 0.15. Third one will come as combination of A and B, that is 0.18. Okay. Now among this 0.18, there are two parts. So one on the left, one on the right. Write the bigger one on the left. So B and A. 0. This is 1. Then there will be E. E is 0.2. And then there will be F, which is 0.35. So this is step 2 or step 1. This is the initial step and this is step 1. I'll name this as 1. In step 2, combine again the two smallest one. So 12 and 15 can be combined, 0.12 and 0.15, and it will become 0.27. Sort according to the weights after combining. So the first will be 0.18. So it will be B and A, 0, 1. 0.8, then 0.2. So it will be E. Then 0.27. This will be C and D. The bigger one is D. D and C. So 0 and 1. 0 and 1. Then the last one will be F and it will be 0.35. This is step 2. Okay, this is step 2. Now, just hold on. Just a minute. Okay. Now, let me go to step 3. I'll clear this. So, In step 3, again take the smallest one. So smallest one will be 0.18 and zero point 0.2. These two will be the smallest one. 0.18 plus 0.2 will give me 0.38. So the first one will be 0.27. So first one will be 0.27. 0.27. In 0.27, this will be D and C. Then it will be F, 0.35. So that will be F. And then it will be 0.38. Okay, 0.38. Where you have D. To this, you will have D and sorry, you will have E, and to this E, you have B and A. And this will be 0.38. Then combine the two smallest. So when you combine two smallest, it will be, so this is step 3. Okay, combine the two smallest. So first one will be B, A, and this will be 0.38. And the two smallest that will combine, this will be F, B, and C. Okay, this will be 0.27 plus 0.35. So this will be 0.62. And this will be step 4. Okay. Now combine the both. Okay, combine both. So this will be F left as 0, right as 1. So in every step, write the left branch to be 0 and the right one to be 1. D and C, 1. E, 0, 1. B and okay, 0 and 1. So this will be, the total weight will be 1.0. Now we can find the average number of bits, and this is step 5. So in 5 steps, we have solved the Huffman tree. Okay. So what we got from this Huffman tree, is code is of 3 bits, and it is 1 1 1 1 1. B's code is of 3 bits, 1 1 0. C's code is of 3 bits, is 0 1 1. D's code 0 1 0. E's code is 1 0, and F's code is 0. Now we want to find average number of bits. To find average number of bits, what we do? We do of summation of the length of the code for X and frequency of occurrence of X. In this case, what we'll do to find average number of bits, for A, the code length is 3 into its frequency 0.08 plus 3 into 0.1 for B plus 3 into 0.12 for C plus 3 into 0.15 for D plus 2 into 0.2 for E plus 2 into 0.35 for F, okay, which is equal to 2.45. Okay, so this is the average number of, okay. So let's understand this. So in a tic-tac-toe game, as a game tree problem, what it is. So if I'm a first player, I have to decide where I'm going to play. So if PC is the first player, he has 9 options to play. For example, he may try to play it here. Okay. Or there's another possibility that the PC might play it here. And in this fashion, there could be 9 different possibilities. So I'm generating a game tree of 9 possibilities. Now, out of these 9 possibilities, as a PC is going to play in only one of the state or one of the node of the tree or one of the vertex of the tree. Okay, let's assume this is there. So if PC plays here in this particular place, then the opponent has 8 chance possibilities to play. Okay, the opponent has 8 possibilities. So one of the possibility for the opponent is that if the PC has played here, he may try to play it here. Okay, that's one of the possibility. So there are 8 possibilities for the opponent to play. Now, as a PC or a computer algorithm, I'll evaluate 2 stages of the game. First stage is a blank board, and I'll evaluate that if I play here, where the opponent will play. So there are 9 positions that I can play with as a PC, and for each position there are 8 possible positions. So 9 8 there are 56, 9 8 are 72. So there are 72 different board positions. Now each of these 72 board positions in the level 2, in this level of the tree, all the 72 board positions will be evaluated on a scale of, let's say, -1 0 1, indicating 1 the PC wins, 0 the game is draw, -1 the opponent wins or the user wins. Okay, so then as a PC, I'll select a board position which takes me to 1. Okay, I'll select a board position which takes me to 1 after two plays. First play of the PC and second play of the player. After that, the game position should be equal to 1. That is the most ideal position where a PC or algorithm should play. The initial board position is 0. Both have equal chance of winning. Okay, so that is called as a two-ply search. This is called as a two-ply search. Ply means chance. So this is one ply, one player going to play, and this is another ply, another player going to play. So try to predict which is the most winning board position before the algorithm actually plays. Okay, that is done using trees. Okay, that is done using. Now this is a tree, and I'll say that now this is tree which is an ordered rooted tree at 0. So what does this mean? That 0 is lexicographically less than 1, less than 1.1, less than 1.2, less than 1.3, less than 2, okay, less than 3, less than 3.1, okay, 3.1 less than 3.1.1, okay, and so forth. And that is what is basically lexicographic ordering. So visiting every vertex of the tree is nothing but it's a traversal. So from 0 I go to 1, from 1 1.1, 1.2, 1.3, from 1.3 I go to 2, from 2 I go to 3, 3 I go to 3.1, 3.1 I go to 3.1.1, 3.1.1, 3.1.1.1, 1.2, 3.1.2, 1.3, then 3.2, then 4, 4.1, 5, 5.1, 5.2, and back to the root of the tree. So this is called as a traversal. Okay. So there are three strategies for traversal in the tree. One is called as pre-order. Second is called as in order. And third is called as post order. So there are three traversal strategies in the in order, pre-order, and post order. So we'll understand each one of the traversals in a better way. So let's assume that there is a tree of this fashion where this is a subtree. We don't know how many levels are there inside this subtree. Okay, so we'll assume this as an abstract part. And then there is a root of the tree denoted by R. Now, what does pre-ordered traversal means? Okay, pre-ordered traversal means that so let us say that this is a tree T rooted at R. If T consists of only R, means there is only one root, then the pre-ordered traversal will be visiting the root. That is, R is the pre-ordered traversal. If suppose the tree contains subtrees T1, T2 up to Tn of root R from left to right, then pre-ordered traversal begins with visiting R. Pre itself means visit the root first. Okay, pre-ordered traversal begins with visiting the root R, and then by continuous traversing of T1 in pre-order. Now T1 itself would be a subtree. So there could be tree under this. Even T1 has to be traversed in pre-order way. Pre-order means visit the root first. Pre-order, then T2 in pre-order and Tn in pre-order. So you visit R first. Okay, you visit R first. So mark R to be visited. Go to T1. Visit T1 in pre-order. Go to T2. Visit T2 in pre-order, and so on and so forth. Complete till Tn in pre-order. So we'll take an example on pre-order first and try to understand the pre-order. So let us write one small example here. So I will draw a tree here. Okay, so this is okay. Suppose this is a tree. Now I want to do in order, that is, I want to do pre-order traversal. So what is pre-order traversal? Visit root. Okay, visit root, and then visit subtrees from left to right. Visit subtrees from left to right. Okay, visit. Now this is a tree completely given to us. So let's understand this. So visit the root. So who is the root? So A. So visit it. Now visit subtrees from left to right. Which is the first subtree of A? So first, to understand, I'll draw it here. So tree starting at B. So B, E, F, B, E, F. Then J and K, J and K. K has 3, N, O, P. So this is one subtree. Okay, this is one subtree. Then the second subtree is at C. So C is only one. Okay, I'm writing subtrees from left to right. The third subtree starts at D. D has 3 children, G, H, I. And G has 2 more, L and M. So we have split this pre-order traversal in 4 subtrees. What is the next subtree that I should visit? I have to visit root. So root has been visited, and visit the trees in left, visit the subtrees in left to right order. So which is the first left subtree? It is under B. Okay, that tree is under subtree under B. So now let's visit that tree. Okay, so first visit is A. Now inside the left subtree also, what I have to do? I have to visit it from root. So mark the root to be visited. So step 2, mark B to be visited. Now if I make B visited, what happens? There will be 2 subtrees again in under B. One starting at E. E will be J and K, and K will be NOP. NOP. And this is E. There will be F. Again, the next part of the tree will remain as it is. Okay, that is C will remain as it is. Okay, then the tree rooted at D will still remain as it is. We have not visited it. So D has 3 children, GHI. Okay, GHI, and G has 2. Let me know its name, L and M. Okay, L and M. This is the stage of the algorithm. Now, visit the subtrees from left to right. So next, after B, the left subtree is under E. So what happens? It will be A visited, B visited. Now the root of the tree at left subtree, that is E visited, and tree will get split into 2 parts. So next will be J and K. Okay, K. So K, and K has 3, N, O, P, F as it is, C as it is, because they are not yet visited, D as it is, G, H, I, and L and M. Okay, now E visited. Now visit the next subtree, left subtree, so it is J. No split is there. Go to the next subtree, it will be K. So what will be the, I am combining 2 steps, A, B, E. Now J visited. J doesn't have subtree. So now K visited, and tree will get split into 3 subtrees. N, O, P. So N is the left subtree, O is the next subtree, P is the next subtree. All 3 visited. Then go to F, visited, C visited, because they are all single trees. Now D will get split into D as it is, and there will be 2 subtrees from D. One starting at G, then H, and then I. G will be L and M. G will be L and M. Now go to the next stage. And go to the next stage. Okay, go to the next stage. That is split this G, visit G, and split. So the next stage of the tree will be, first A, then B, then E, then J, then K, N, O, P, F, C, D, G, L, M, H, and I. So this is the pre-order traversal. This is the pre-order traversal of the. Now in order traversal, what is the requirement? Again, we'll go to the typical first diagram. That is, we'll assume that so this is T1, T2, and Tn. This is the tree at root R. Now, if the tree contains only one root node, then in order traversal is R itself. But if the tree contains a root R and subtrees T1, T2, Tn from left to right, then what does in order traversal indicates that, or how does the in order traversal works is that first visit T1, visit T1. Okay, T1 is visited in in order. T1 is visited in order. Then the next step is visit R and then visit T2 to Tn subtrees in order. Visit T2 to Tn subtrees in order. So now let's understand with the same tree. Again, we'll draw the same tree. Okay. So I'll draw it again. I expect you all to draw this tree on the book. Okay. So I'll draw it fast. A, B, C, D. B split at 2 times. E, F. D split at 3 times. G, H, and I. Okay. E split at again 1, that is J. F split at, sorry, E split at J and K. K split at 3 times, that is N, O, P. F is not split. G split only twice, L and M. So now let's do the in order way of this. Okay. Now let's understand this. Okay. So what is the left subtree with respect to A? It is all the tree at B. Okay. So left subtree with respect to A is all the tree at B. So B, E and F, E, J and K, and K, N, O, and P. So this is the left subtree. This is B. So visit the left subtree in order way. Then visit root. So it is A. Then visit the next subtree. That will be C. And this has to be visited in order way. And the next subtree again in order way. So D, G, and H, and G, H, and I, and G as L and okay, G as L and M. So this will be the first stage of the in order traversal. But what is the second restriction? That visit these trees in order way. So B in order way, the first subtree, A in order way, C in order way, and D also in order way. So when I say in order way, so B, the tree's root is now B. So left subtree of B is E, the tree under E, and this is F. So that will be visited first. So this will get converted to tree under E. So this will be J and K having 3, N, O, P. Then it will be B, that is the root of the tree. Then F, that is the another left subtree, right subtree of one of the subtree of B. Then A, the first root. Then C. Okay, I can apply same logic to D also. Okay, so for D, it will be G first, tree at G in order way. So G will be split as L and M. Then it will be D because D is the root of the tree. Then H, and then I. Okay, now again, the same logic has to be applied. So with respect to E, I is the left subtree. So, sorry, J is the first left subtree. So I'll say J. Then root of the tree, it will be E. It will be E. Then the next subtree, so it will be at K, and K will be N, O, and P. Then the remaining part of the tree, so B, F, A, C. Now with G, the left subtree is L. So L, then the root of the tree. It is in order, so root of the tree. So G, then the right subtrees. So M, D, H, and I. I will split the next part of the tree. It will be J as it is, E as it is. Now for K, N, O, P, the left subtree is N. So N, then root of the tree. So K, O, P, B, F, A, C, L, G, M, D, H, and I. So this is the in order traversal of the tree. Okay, in order. That is, we'll go to the next point, that is post order traversal. Again, we'll go to the typical tree first. So the typical tree, let's say it is rooted at R, T1, T2, Tn. Now what does post means? Visit the root last. So visit the subtree T1 in a post order way, T2 in the post order way, Tn in a post order way, and then mark the root R to be visited. That is called as post order. Okay, called as post order. So let's do it for the same tree again. So A, B, C, D. B has E and F. D has G, H, and I. Okay. E has J and K. K has N, O, P. G has L and M. Now let's understand to do it in a post order way. So now in a post order way, what it says that visit the subtrees in a post order way and then the root of the tree. So with respect to A, which is the first subtree, it is at B. So B, E and F, F, J and K, and N, O, and P. Okay, this is B. Then the next subtree is C. Next subtree is D, which has G, H, I, and G has L and M. G has L and M. And then it will be root of the tree, that is A. Okay, then it will be root of the tree, that is A. Now, same post order has to be applied to B, the subtree at B, subtree at C, and subtree at D. So for B, B will get split into E, F, and then B will be marked as visited. Similarly, D will be split into G, H, and I, and then D will be marked as visited. So apply post order traversal for B and D. Okay, so let's go to the next stage and apply it. So what will happen to here B in a post order traversal? Oh, so let's apply the post order traversal. So it will be E. E will be split as J, K, and K as N, O, P. Then the next subtree. So next subtree will be F, then B. Okay, C as it is. D will be split as G, which will be L and M. Then next subtree H, then I, then D, and then A, the main root of the tree. Okay. Now apply the same logic to E. So E will be splitted as the first left subtree J, then the next right subtree K, N, O, P. Okay. Then E itself, post order, so root last, F, B, C. Now for G again apply the post order traversal. So first L, then M, and then G. Okay, so the as root is G now, H, I, D, and A. Apply again. So J. Now post order to the subtree rooted at K. So N is the leftmost subtree, then O, then P, then K, then E, then F, B, C, L, M, G, H, I, D, and last is A. So this is the post order traversal. Okay, post order traversal of the tree. Okay, so do in order, pre-order, and post order of this tree, and post your answers in the chat. Okay, so these are the three in order traversals of the tree. So let's